Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Hyderabad, India. Today we are going to study and discuss about the velocity and acceleration analysis of various mechanisms. So here we are going to use the method is graphical method, that is relative velocity method. In order to find out the velocity of various links of a mechanism, there are two methods are there. Those two methods are graphical methods, but first method is a relative velocity method. Relative velocity method, and second one is IC method. That means it is instantaneous center method. IC method, instantaneous center method. So here we are going to discuss in this session by using relative velocity method. We are going to do velocity analysis and acceleration analysis of various mechanisms. What is relative velocity method? The relative velocity method means, suppose when two bodies are moving in parallel direction, moving parallel, then what is the relative velocity? The relative velocity of one body with respect to another body. In this figure, we are considering there are two bodies, A and B. This body A is having the velocity of VA and the body B having the velocity of VB. The velocity of body A is greater than the velocity of body B. So the relative velocity of A with respect to B, that is VAB. That VAB is vector difference of VA and VB, that is equal to VA minus VB. How to denote this in vector form? That is velocity of A with respect to B, that is VAB, that is BA direction, and whereas velocity of VA with minus VB, this VA is velocity of A with respect to reference line, that is called absolute velocity. With respect to O, that is VAO, that is OA, O to A. And velocity of B with respect to O, that is VBO, that is VOB. That means that is OA minus OB. Velocity of A with respect to B equal to velocity of A minus velocity of B. Now it is in parallel lines. So the direction, velocity vector, velocity diagram we are going to do here. VA, VB up to here and VA. So that is this portion VA minus VB, that means this is the portion that is B to A, that is velocity of A with respect to B. If you measure this, so these are the lines, that is vector forms we have drawn with some suitable scale. So velocity of B, the velocity of B with respect to A, VBA equal to velocity of B minus vector difference of velocity of B and velocity of A, that is VB minus VA. What is that meaning here? This vector difference is velocity of A with respect to B, that is VA minus VB. If you want to say velocity of B with respect to A, then we have to represent VBA, that is VBA equal to VB minus VA. We want velocity of A with respect to B, that means VA minus VB. Velocity of B with respect to A, that is VBA, that equal to VB minus VA. This is the representation. The first letter indicates particular body, that is velocity of B, and in relation to A, that is VBA, that is VB minus VA. That is what we have represented. How to represent in vector form? In vector form, A to B, we have to write the direction, that equal to O to B minus O to A. This is the vectorial form of the relative velocity VBA, that is velocity of B with respect to A. So this is the manner. So in order to understand better, suppose if the person is traveling in a bus, if the person is traveling in a bus, and if the person is traveling in a bus, so and moving inside the bus, this person is also moving inside the bus. The person name is P, the bus is B, with respect to it is moving on the road, that is R. Velocity of the person with respect to bus, that is VPB, and velocity of the bus with respect to road, that is VBR. Pay attention. If you want velocity of the person with respect to road, velocity of the person with respect to road, VPR, equal to velocity of the person with respect to bus plus velocity of the bus with respect to road. That is the manner. Now, after getting this equation, velocity equation, velocity of the bus with respect to velocity of the person with respect to bus equal to velocity of the person with respect to road minus velocity of the bus with respect to road. This is the manner we are going to find out. Again, if the person is moving inside a bus, is walking, if you want to find out the velocity of the person with respect to the road, ROAD road, then what happens? Velocity of the person, this person is moving in the bus, that means velocity of the person with respect to bus, VPB, plus velocity of the bus is moving on the road, that is VBR, VPB plus VBR. Velocity of the person with respect to road equal to velocity of the person with respect to bus plus velocity of the bus with respect to road, VPB plus VBR. Similarly, if the person is walking or running in a plane, if the person is running in a aeroplane, person is running in a plane. If you want to find out the velocity of the person with respect to Earth planet, velocity of the person with respect to Earth equal to velocity of the person with respect to the plane, aeroplane, plus velocity of the aeroplane with respect to Earth. So that is the manner we have to find out we have to write down the velocity equation. So that is the introduction of finding out the velocity equations and vector forms of various bodies. In this, there are three case studies we studied. One is when two bodies are moving parallelly. Another one is velocity of the person when the person is moving inside the bus. And third case is when the person is moving inside the plane, aeroplane. So thus we have to write the velocity equations in order to write down vector forms, and then we go for vector diagrams. Now consider the next case is here two bodies are moving. One body is horizontal, another body is inclined, VB, VA and VB. Suppose now consider the body B is moving in an inclined direction as shown in figure, and the relative velocity of A with respect to B. How to find out? Maybe obtained. Which law we have to use? We have to use parallelogram of velocities or triangle of velocities. We have to draw the diagram. What is the triangle of velocities? Take any point, any fixed point O, and draw a vector OA. Draw a vector OA. Both we know that it represents, OA represents VA, velocity of the A, in magnitude and direction with some suitable scale. Similarly, draw a vector OB represents VB in magnitude and direction. Both magnitude and directions we know. Then we have to draw the lines. Then the relative velocity of the A and B with respect to B, it comes when you join the end of B and join with the end point of A. This is velocity of A with respect to B. VAB, velocity of the A with respect to B, VAB. You measure with the help of the scale the length of the vector AB, that is equal to length of the vector velocity of A, VAB, that is from, we are writing vector form. What is that vector form is? BA, B to A. You measure it with the help of the scale, then you find out the length. That length gives the quantity of velocity of A with respect to B, VAB. So how to start? We have drawn, but we have to find out the velocity equation, that is velocity of A with respect to B, that equal to VA minus VB. How to draw the vector? With the help of the vector equation, velocity of A with respect to VAB, that means B to A equal to velocity of A with respect to A, that is absolute velocity. So AO, and it is also absolute velocity, that means OA minus OB. OA minus OB. OA minus OB. Okay, that is the relative velocity, that is OA minus OB. We found out here the velocity of A with respect to B. Suppose you want velocity of the B with respect to A. What is the velocity of B with respect to A? You measure the same, that is the AB vector, then you convert it to the scale, that it comes velocity of the B with respect to A. Suppose if you want velocity of the B with respect to A, the direction should be velocity of the B with respect to A. What is the vector form? That is A to B should be the direction. So then the direction of the vector, this direction of the vector becomes reverse direction. This is the way will be there. Velocity of the B with respect to A. That is the vector is from A to B, from point A to point B direction. This vector equation represents, what is the importance of vector equation and what is the importance of velocity equation? Velocity equation represents how to find out the relative velocities and various velocities of different links. But this vector equation represents how to go for direction. This is a velocity equation, VA minus VB. What is the vector form? This is how to start from point B to point A. This is point O to point A and point O to point B. So O to A we have gone. That is O to A. From point O to A, that is the direction O to A. And OB, O to B. This is O to B, point O to point B. This is the direction. Why not the direction B? B to O. No, B to O represents velocity of O with respect to B. So this OB means velocity of B with respect to O. Velocity of B with respect to O. From where the direction should be? From O to B. That is O to B. So OA minus OB. Then what is the direction? Which direction? From point B to point A. That is point B to point A. We have drawn here. Point B to point A. Thus represents point B to point A. VBA, velocity of B with respect to A. Okay, VBA, velocity of B with respect to A, that is VBA. But here, vector notation is velocity of A with respect to A. That means it is point B to point A it comes. Now, what is motion of a link? So far we have covered again when two bodies are moving parallelly, when two bodies are moving parallel direction. Now one body is parallel, one body is horizontal, another body with some inclination. Then what is the relative velocity? Now we are coming to the point of what is the velocity of the link. Why we have to study the velocity of the link? What is the motion of a link? Because group of links is known as mechanism and having some motion from one link to another link. The mechanism. So a mechanism consists of various links with the different motions. Now, in this motion of a link, is the figure represents this is the link having. So consider 2 points on the link. Okay, a rigid link AB. Now let one of extremities be on the link of the link move relative to A in which direction? Clockwise direction with an angular velocity omega. Now since the distance between A and B remains the same, therefore there can be no relative motion between there is no relative motion between A and B along the line AB, because these points A, C, B all are on the same link. Okay, there is no relative motion between them. Now, the relative motion of B with respect to A, must be perpendicular to AB. That's why we have represented here velocity of B with respect to A is perpendicular to link AB. Okay, that is very important. The velocity always the vector, the velocity is link is perpendicular to with respect to B to A is perpendicular to A to B, perpendicular to AB. Now in this, hence velocity of any point on a link with respect to another point on the same link is always perpendicular to the line joining these points on the configuration diagram or space diagram. This is a configuration diagram or space diagram. This rule is very, very important rule. Very, very important rule. Very, very important rule. So this is point A and point B. Point A to point B. That is VBA. Now, in configuration diagram, suppose the configuration diagram is slider crank mechanism. The slider crank mechanism consists of various links, fixed link, and second link 2 is a crank, link 3 is a connecting rod, link 4 is a slider. So what is the direction for link 2 and link 3? The velocities are in diagrams, it is perpendicular to link 3. Suppose, so link 2 and 3 is, whereas link 4, the motion is a linear motion, it is a horizontal line. But for link 2 and 3, this link 2 and 3 lines becomes the velocity diagram lines in space diagram. We have to do, it will be perpendicular based on it is in counterclockwise direction. It will be the vector, that is velocity of the 2 with respect to fixed link V21. And it is in clockwise direction, it will be in this direction. But it should be a normal to the link 2 in the space diagram. Okay, that is the way we will draw the velocity diagram. Now, here we are going to find out the velocity of a point on a link by relative velocity method. The relative velocity method is based upon the relative velocity of various points on the link Consider 2 points A and B on a link as shown figure. Let the absolute velocity of the point A, that is VA, is known in magnitude and direction. Okay, and the absolute velocity of the B, that is VB, is known in direction only. Is known in direction only. We don't know the magnitude. Then the velocity of the B may be determined. How to find out the velocity of B? Velocity of A, point A, we know both the magnitude and direction, so we have drawn. But whereas the velocity of B, don't know the magnitude. No, velocity of the B may be determined. The velocity may be determined by drawing the velocity diagram. But understand, but here there are two conditions are there. Absolute velocity we know, magnitude and direction, and absolute velocity of the point B, and we don't at the point B, that is VB, is known only in direction. We don't know the we know only direction, we don't know the magnitude. Then how to start? Again, point 1. Take some convenient point O known as a pole. Convenient point known as a pole, that is called, this is the pole, starting point. Through O, draw a OA line, parallel to and equal to VA to some suitable scale. This is the VA we are drawing. This is the parallel line. VA was given to some suitable scale. Next, through point A, draw a line perpendicular to AB. This line will represent the velocity of B with respect to A, that is VBA. We know the direction, we don't know the magnitude. Next, through point O, through the pole O, draw a line perpendicular to AB. Draw a line perpendicular to AB. This line will represent the velocity of B with respect to A. Okay, this is the line represents velocity of B with respect to A. Through point O, draw a line parallel to VB, intersecting the VBA at B. This is what intersecting the VB at A. So draw a line parallel to here. Parallel to VB means this is the parallel to VB line. Perpendicular to AB means this is the AB line. These lines are perpendicular to AB. So then if we join the line perpendicular to VB, then it will be joined AB vector and OB intersects at point B. So measure what is the OB vector, that is vector O to B you measure, which gives velocity of the B. Okay, velocity of the point B. Thus we have to find out how to find out the velocity of B with respect to O. This is the methodology is mentioned, step-by-step procedure. Again, let us begin one more time to understand better. Now, take how to find out again the relative method. The relative velocity method is based upon the relative velocity of various points on the link. Let us consider 2 points. The 2 points are A and B on a link. Let the absolute velocity of the point A, that is VA was given direction, both magnitude and direction, and velocity of the point B only having direction only, we don't know the magnitude, but we have to find out the magnitude of velocity of the point B. But here how to start? Then the velocity of the B, how to find out the velocity of the B? The velocity of B will be determined by drawing the velocity diagram. How to draw the velocity diagram? Let us begin. Take some convenient point O known as pole and draw OA parallel and equal to VA to some suitable scale. Then through A, draw a line perpendicular to AB. This is the AB line. This line will represent the velocity of B with respect to A. That is the velocity of B with respect to A. But we want velocity of B with respect to O. How to draw it? Then through O, draw a line parallel to VB. VB was given, magnitude and magnitude was not given, only direction is given. With this VB line, draw a parallel line. What is that parallel line? This is a parallel line. That line intersects the AB line at point B. And if you measure from the distance from VB to O, O to B, that is the velocity of B with respect to O. Okay, the velocity of B. That is OB, O to B direction. What is the direction? O to B. What is the direction of here? O to A. What is the direction of A to B? That is here. That is velocity of B with respect to A equal to, okay, that is velocity of B with respect to A, that equal to velocity of A with respect to O minus velocity of B with respect to O. Now, VAO, that is the meaning, okay. What is the vector form? The vector form is A to B equal to O to A minus O to B. O to A and O to B. These are the directions represents. Which gives the required velocity of point B, VB, to the scale. So thus we will draw the velocity diagram by using relative velocity method. Okay. Now I want to discuss more in order to make you to understand. So very important, this slide. Okay. In this figure, even though it is on the link on the body, but there are various points are there. The data was given here. Velocity of A, we know both magnitude and direction. Magnitude and direction both are known. Velocity of B, point B, we know only magnitude. Only direction, only direction. No magnitude. And next point is that velocity of BA. This BA also, let the absolute, yes. In this BA also, we know only direction, but we don't know the magnitude. So how to find out velocity of the point B? Velocity of B means that is absolute velocity with respect to reference line, that is the O. Velocity of BA means velocity of B with respect to A, that is in relation to A. Velocity of A means it is absolute velocity. Velocity of A with respect to point O, that is a reference point. If we understand broadly, there are two types of velocities. One is absolute velocity, another one is relative velocity. What is absolute velocity? Absolute velocity, suppose I am driving on a vehicle on the road, or suppose I am running on the road. My velocity, velocity of my body is absolute velocity with respect to the fixed point. That is, the fixed is the road. Suppose if I am driving on the vehicle, I am riding on the vehicle, my velocity is, suppose velocity of my body is not absolute velocity. If you want absolute velocity, then what to do? Velocity of my body with respect to road, that is reference point, is velocity of the person body with respect to vehicle plus velocity of the vehicle with respect to the road. So here there are two velocities are there, that is velocity A and velocity of B both are absolute velocities. Velocity of AB, velocity of A with respect to E is relative velocity. Now by default VA and VB means absolute, means with respect to O. With respect to B, we don't mention every time VAO, VBO. No, VA, VB both are absolute velocities, whereas velocity of B with respect to BA or VAB or VBA, that velocity is relative velocity. So there are two velocities, again two types, absolute and relative. So we will use the parameters of magnitude and directions, and we will find out the unknown parameter of magnitude and direction of some another components, velocities. In this slide, what is happening here? We know the velocity of A, both magnitude and direction. So that's why how it will begin. Let us begin. We have taken the some point O. We know the velocity of A, both magnitude and direction. Suppose VA was given some 15 meter per second. That 15 meter per second considered as 5 meter per second equal to 1 centimeter. Then 15 meter per second, that means 3 centimeters. With the 3 centimeters length, you draw a vector line that is parallel to velocity of VA. If VA was not given, we have to draw a line, velocity perpendicular to the link. Now VA, you draw a parallel line, that is OA. We know the magnitude of VBA, but we don't know the direct magnitude VBA. We know the direction. Next, what to do? Velocity of VBA, that is A to B. Draw a line. Okay. Now, then how to start this one? Next one. Next, we don't know the magnitude of VB, but we know the direction. The direction is what? This is the direction of VB. Draw a line parallel to the vector VB. Now, this VB intersects VBA at point B. Now, you measure VOB, that is velocity of B with respect to O, that is velocity of the B. That OB is obtained some value. What is that value? That VO to B is value equal to some 5 centimeters. That convert into scale. What is the VBO equal to? 5 into, as I mentioned before, 5 meter per second equal to 1 centimeter. Then what happens? 5 centimeters means 5 into 5. That is 25 meter per second. Thus, we will find out the velocity of B with respect to O. Okay. That is the introduction of relative velocity method. Okay. All right. Now, what is the next one? Next case. Suppose if there is midpoint is there. Here, point C is the midpoint. How to find out the velocity of that midpoint? The method is that, okay, how to find out? We know the links. AC by AB, this is a vector form we follow. AC by AB equal to vector form of AC by AB. We know that AC, we know that AB. The unknown vector, this one, we know that AC, then AC equal to capital AC by capital AB times small ab. How to? Just let us see. The vector AB which represents velocity of B with respect to A is known, that is velocity of imagine of the link AB. The absolute velocity of the C on AB may be determined by dividing the vector AB at C at the ratio of C divides the AB. That is AC by AB, that equal to capital AC by capital AB. Now join OC. This is what, let us see how to find out. This is a diagram we have drawn so far. Now what to find out? Now what to do? Join OC. We have to divide this line. That line, make it that AC comes out from this equation mark the point that AC, then join O to C. Then it is obtained as this OC length or velocity of OC. OC is vector OC is the length of the velocity vector. OC is the velocity of point C with respect to O, that is VC. Thus we will find out VC. Okay. Now if you want to find out velocity of the C with respect to A, you measure VCA. This is the distance, that is A to C distance, VCA. Now if you want to measure velocity of the C with respect to B, velocity of the C with respect to B, that you measure the distance, B to C distance. Thus you will find out the way velocities you want. Suppose if you want velocity of B with respect to O, you measure BO. Velocity of B with respect to C, VBC, that is C to B length, distance. Velocity of B with respect to C. Thus you can find out various points on the link and with respect to other points by using this relative velocity method. Now the angular velocity of the link AB may be found by dividing the relative velocity. What is that relative velocity? Angular velocity of AB, angular link VAB equal to, we know that V equal to R omega, that is omega AB. We know the length or radius if we know dimension. If you want to VAB, just now we found out, we observed. Now how comes angular velocity omega AB? That omega AB equal to relative velocity of A with respect to B or B with respect to A, VAB by, what is that R? That R equal to length of that link AB, Thus we will find out the angular velocity of A with respect to B or angular velocity of B with respect to A. Suppose if you want to find out the angular velocity of VA, or if you want to find out the angular velocity of B with respect to O, that is omega BO, we can find out, that is VBO by length of the link OB. Okay. Thus we can find out mathematically by using these relations after drawing the velocity diagram and measuring the values of related velocity values of different points on different links or different links of different mechanisms. We can find out this angular velocities and absolute velocities and relative velocities of various links. So in this session we have covered what is when two bodies are moving in parallel and what is the relative velocity, and when one body is moving horizontal, another body is moving inclined with some inclination, and what is the relative velocity, and also the relative velocity method of a link, and what are the types of velocities, that is absolute velocity and relative velocities, and with the examples of when the person traveling in a bus and when the person traveling in a plane, and what is the relative velocity, what are the relative velocities of various links we have studied in this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.